Okay, so some people have been having some issues with lengths of arcs, perimeters of sectors and areas of sectors. So I'm just going to do a quick video of my own to see whether we can tidy this up. So first of all, we're going to work out the length of the arc of this shape here. So the arc is the curved bit, just the curved bit. Whoops. Okay. Now, to work out this, if we imagine it was a full circle, the arc is part of the circumference of that circle. So to work out the circumference of the circle, we use 2 pi r, which is 2 times pi times the radius of, if it was a full circle, the full circle. So this here is our radius. In fact, so is this here. These two lines here both go to the centre of our circle. They're both radiuses, which actually means that they are both the same length. So this length here is also 5 centimetres. Now, because we don't want a full circumference of a full circle, we only want a little bit of it, we want to just find a fraction of our circumference. So we've got 80 degrees that's making up this arc. If our full circle was 360 degrees, we only want 80 out of 360 degrees. If we then use our circumference, so we're going to times that fraction by 2 pi and the radius, which in this case is 5. And if we type that into our calculator, then we will get the length of the arc. Okay, so fraction button, 80 360 times 2 times pi, so that's shift and the bottom button, bottom middle, times 5. So that's not a decimal answer, so if you press the SD button it will turn it into a decimal. So that means that the length of this arc is 6.98, correct to 2 decimal places, centimetres, because we were working in centimetres. Now, if we want the perimeter of a sector, then we need to find the length of the arc, like we've done just here, but we've then got to add on these two radiuses. So it's the length of the arc plus 2 radii. Okay, so we would work out the length of the curved bit as we did up here, and then we would add on our 2 radii. So for this one, the perimeter would be 6.98. That's our length of our arc, plus 5, which will give us 16.98 centimetres, and that's correct to 2 decimal places again. Now, if we want the area of a sector, so this time we are not looking for this curved length and we're not adding on the straight bits, we're looking for an actual area. So we're looking for this bit here. What we would need to do here is we would need to use our area of a circle formula, which is pi r squared, or pi times the radius squared. Again, in a similar fashion to the length of the arc, if we were going to imagine this was a whole circle, we would do pi r squared, but we only want a fraction of that whole circle. So we want 135 out of the 360 degrees make up a whole circle. And then we're going to times that fraction by pi times the radius, which again is this length here, going from the centre out to the circumference. We've got another radius there, but we just need 1 this time. So we'd be timesing by 8 squared. And if we type that into our calculator, we get the area of our sector. So fraction button, 135, 135 over 360 times by pi, shift bottom middle button, times by 8 squared. And again, it's given us not as a decimal, so if we press the SD button, if we're going to round this to 2 decimal places, it would be 17.39, and then we'd have to round the 9 up, so actually become, sorry, not 1775, so it becomes 75.40. Use the white colour pen. And that will be centimetres squared because it's an area and we were working in centimetres. Now, some of you may not have a calculator with the fraction button like this. The other way that we can deal with the fraction bit on our calculator, if we just delete that, is I can open a bracket and then do my numerator, 135, divided by my denominator, 360, and then close the bracket. And that's how we can do it if your calculator doesn't have the fraction button. Again, it comes up with that 24 pi, and if we press, we get the same answer.